1.3 max or mins of quadratic functions. Okay, so let's just recall quickly. A quadratic function in standard form is in this form here, where a does not equal 0 because we need an x squared term. A quadratic function in vertex form looks like this, where hk is the vertex, h being the axisymmetry, and then k being the max or minimal value. Okay, and when a is greater than 0, so when a is positive, the parabola opens up, and therefore we get a minimum. And when a is less than 0, the parabola opens down, and therefore we get a maximum. Okay, so we already went over completing the square in the recap from last year. So let's do it again, and then we're going to build on it. Okay, so completing the square is the process of expressing a quadratic relation, okay, and changing it from vertex form into, from standard form into vertex form. Okay, so standard form, vertex form. And these two forms will be algebraically equivalent. They're just going to look a little bit differently. Okay, so for the first example, I'm going to go through all the steps one by one, and then I'm going to just reference them after. Okay, so number one, what we do is we group the terms with the x's in them. So x squared and 6x. Okay, and then we have to factor out the coefficient of the x squared term. Note that the coefficient of the x squared term has to be 1. Well, it's already 1, so we can just skip that little step there, and we can move on to 2. So we're going to complete the square by making this bracket a perfect square trinomial. So we're going to take the coefficient of the x term, which is 6. We're going to go to the side of our paper, and we're going to divide it by 2, which is 3, and we're going to square it, which is 9. Okay, divide by 2, square it. Okay, number 2, what we're going to do is we're going to add and subtract this 9 inside of the bracket. So plus 9 minus 9. Okay, and then just bring down the plus 8. As you can see, plus 9 minus 9, that's just adding 0. What we're doing is we're doing this in order to make this equation look a little bit differently, but it's algebraically equivalent. Okay, number 3, remove the negative term. So we're going to bring that negative 9 outside of the bracket. We're left with a trinomial inside of the bracket in which we have to factor, and then we're left with plus 8 minus 9. So when we factor this trinomial, we get x minus 3 squared, and then when we simplify plus 8 minus 9, we get negative 1. Okay. The second example. So this is the example where we actually have to factor out this 2 out of the first two terms. Okay, so we have y equals 2, x squared minus 6x plus 3. Okay, now we take this x term, we go to the side of our paper, and we divide it by 2, which is 3, and then we square it. So again, randomly, we get 9. So we're going to go inside of that bracket, and we're going to go plus 9 minus 9. Okay, let's bring out this negative 9. When we bring out the negative 9, because it was inside the bracket, the factor of 2 applies to it. So we multiply it by 2, and we get 2 x squared minus 6x plus 9. And then we get negative 18 plus 3. And now we can go ahead and factor the trinomial, x minus 3 squared, and then add negative 18 plus 3, I get negative 15. Okay, and this is how we write a quadratic relation given in standard form in vertex form by completing the square. Okay, this time we're going to build. This time it says determine the optimal value, okay, so the max or the min. And we're going to do this by completing the square. So let's complete the square first. Bracket the first two terms. Take that x term, divide it by 2. 5, square it, we get 25. Okay, so inside of this bracket, we want to put plus 25 minus 25. And then just bring down the negative 20. We're going to bring this negative 25 out. So we're going to get the trinomial x squared plus 10x plus 25. Now we have negative 20, negative 25 outside. We're going to factor the trinomial, y equals x plus 5 squared, and we're going to subtract the 45. So negative 20 minus 25 is negative 45. Okay, our vertex here is negative 5, comma, negative 45. Okay, this is our h value, this is our k value. So when we talked about optimal value, what we're talking about is that y value. This opens up because the leading coefficient is positive. So we're going to have a min of negative 45. Okay, next one. We have to divide out that negative 4 because we need the leading coefficient to be 1. Okay, so we get x squared minus 2x minus 1 on the outside. We don't have to factor out that negative 4 from the 1 because we're grouping the first two terms. Now, take that x term to the side of your paper, divide by 2, and then square it. So we're going to take that 1 and we're going to put it inside of the bracket, and we're going to write plus 1 minus 1. When we take this negative 1 outside of the bracket, it multiplies by the negative 4. So the trinomial that we get inside of the bracket is x squared minus 2x plus 1, and then we have minus 1 plus 4. Okay, so bring down the 4. We're going to factor the trinomial. I get x minus 1 squared. And then we're going to add these. I get plus 3. So our vertex is 1, 3. So our optimal value the coefficient is negative 4, so it opens down. There's going to be a maximum of 3. Okay, another approach, averaging the zeros. So how we do that is we solve for the vertex by averaging the zeros. So let's solve for h, the h value, so the x value of the vertex. To find the axis of symmetry, we average out the zeros. Okay, so we add them and divide them by 2. Then what we do is we take that number, sub it back in, and we can solve for k. Okay, so this is an easy way of doing this if we have our equation in factored form, or if it's easily factorable. So solve for the optimal value by first using the roots. So it tells us what to do to solve for the h value, then state whether it's a max or a min. Okay, so this is already factored. So we have x plus 5 equals 0, and we bring that over. X equals negative 5 is one of our factors. Then x minus 1 equals 0. Bring that over. X equals 1. Okay, so we take these two numbers and we average them out. So negative 5 plus 1 divided by 2. We get negative 4 divided by 2, so we get negative 2. Now let's set that negative 2 right back into the original. Y equals 2, negative 2 plus 5, negative 2 minus 1. Okay, so we get 3 and then negative 3, which is negative 9, negative 18. Okay, so our vertex is going to be negative 2, negative 18, and this is going to be, and we have an optimal value of negative 18. This is going to be a minimum because the leading coefficient here is 2, so it opens up. So we have a min at negative 18. Okay, next one. So we have to go ahead and factor this. So we have y equals, is that better? Yeah. Okay, y equals, so what two numbers multiply to 10 and add to 7? So numbers that multiply to 10 are 1 and 10, 2 and 5. These add to 7. So we have x plus 2, x plus 5. So when we branch these out, and I'm going to skip this step of rearranging just because these are straightforward, we get two x-intercepts of -2 and -5. So when we go ahead and we add these together and we average them out, we get -7/2. And that's fine. Like you can do -3.5, and that's fine as well. As long as that decimal stops and it's a neat decimal, I'm okay with that. So we're going to go ahead and sub in -3.5 squared plus 7, -3.5, and then plus 10. Okay, so going down this, putting this all into my calculator, I get 56.75. And you can go ahead and go through like the actual calculations, that's fine. So we have a vertex of -3.5, comma 56.75. Okay, this parabola opens up, so we have a minimum, and we have a minimum of 56.75. Okay, remember the optimal value is the y value.